Hello, everyone, and welcome to the Getting Started with the PDM Collection webinar. My name is Juliana, and I work in marketing here at MicroCAD. And today's presenter is James Dumont, our applications engineer. At today's webinar, we will go over how to get started with the project design and manufacturing collection, and what can be achieved with the ultimate set of engineering apps. And throughout the webinar, you can also ask any questions at any given point on the left-hand corner. You can ask Jim to revisit a step or ask any questions. This is your time, and we want you to make the most of it. And in the upper left-hand corner, you will find links to our social media and website. Also our YouTube channel, and make sure to check that one because we post all of our webinars there at the end, so you can share with colleagues or rewatch it on your own time. And without further ado, we'll pass it on to James. Hey, Jim.
Thank you very much. Jim is fine. James, either one is fine. I answered to both, not a problem. All right, let me share my screen. And let's share this guy. So I do want to thank everyone for attending our webinar today. And Juliana and I are very excited to talk to you about how do you extend your capabilities beyond 3D. Many users have the Inventor, but I get asked many times, extremely frequently, what else is in the collection and how can I benefit from it? I'm going to try to explore that today and then hopefully give you some ideas and things to look into getting back to MicroCAD and how we can help you excel with your product design and manufacturing collection. And if you don't have it, you're going to look at all the different capabilities that it does offer. So the product design collection, or PDM for short, it has so many capabilities and so many products within it. It's very similar to Microsoft Office. It's a suite of products. Office contains Word, Excel, PowerPoint, Outlook. The product design collection includes Inventor, AutoCAD, AutoCAD Electrical, AutoCAD Architecture, Navisworks, 3ds Max. We could spend the next 3 days just demonstrating the different products and their capabilities. So it's going to be a real short subset. We have a limited amount of time to try to cover as much information as possible. Some of the information I'm going to show you will be live. Some of it will be PowerPoint, and some of it will be videos. At any point in time, as Juliana said, ask any questions. You can post them in the chat area. And also, if there's anything that you want us to dive deeper into, please reach out to us and we can schedule some time so we can actually talk about your needs and find the best solution for you. So we are here to talk about more than just designing great products. We're talking about your entire product development process, and it's being done by using a collection of integrated applications. As I mentioned, the collection we are discussing is the product design and manufacturing collection, or PDM. It includes the tools that you need to develop your ideas, and based on that, you can also simulate them to make sure they work. You can analyze the dimension tolerances. You can create CAM, toolpath strategies, and factory layout for optimizing throughput. And all that data for every tool you use is stored and managed in a secure project. It's those capabilities that enable you to be more innovative. And with that, being more innovative, hopefully you'll be able to win more business. You'll be able to streamline your manufacturing and improve your overall product performance. We're going to show you some of the reasons why. First, your design work is the foundation for everything. That's why we're starting with Inventor. The general capabilities of Inventor, I'm assuming that most of you are aware of some of these capabilities before attending the seminar. If not, welcome, and you'll see some exciting things in Inventor. Because most people are familiar with this, I'm only going to cover a few points before we dive into the other products in the collection. So what makes Inventor such a great design tool? It enables you as a designer or engineer to focus on your design and less on how to use feature controls. Where are the icons? Where are the menus? Where are the picks and the clicks? you're going to find specialized modeling tools to speed up your design. And some of those sheet metal tools that are available to quickly create the features in your model and get an accurate flat pattern to your laser cutter. There's a frame generator that models a 3D as you specify the skeletal structure and cross-section choice for each member. The tube and pipe for assemblies, which includes routing rigid pipes, bent tubes, flexible hoses for machine designs, and other consumer products. This is something that's coming up an awful lot in our conversation with customers, is the tube and pipe. We have so many customers in the last 2 years that are able to benefit from this, and they were not even aware that was built into the core product. In addition to that, you have the flexible modeling methods that are there to remove any hurdles. Parametrics, direct editing, freeform capabilities, you can use them all together at the same time. You can integrate them without any issues. You don't have to be in a special environment. Everything's done inside of Inventor. So with that being said, let's take a look at the two of these, the frame generator and the tube and pipe. I'm going to switch over to Inventor. So here is an assembly. And basically, it's just a quick structure. I have a part that signifies my envelope. Where do I want my structure frame to be? And all I have to do is use the tools within Inventor to do that. I'm going to insert frames. This is the actual frame generator. I just have to get my content. I just rebooted my system, so I was not logged in. We'll try that once more. There we go. So the frames, the content center frames, the structural tubes, the I-beams, the C-channels, all of that is stored in libraries. I just needed access to those libraries. So it's loading them up now. So in here, I decide, what am I looking to do? So I want to put some structure on the bottom, maybe some C-channel. And then I specify the size. I'm going to go with the standard, 3 by 3.5. That's a standard shape. And all I'm going to do is just hover over the edge. And my edge signifies the outer extent. So I want to make sure my frame is within that. So I'm just going to walk around and place my channel all around. This is going to create all of the necessary components that'll make up this frame generated assembly. The advantage here is these are pre-built library definitions. I'm able to bring them in their standards or standardize. I'm able to pick edges. I don't have to place and constrain and then make things adaptive. It just works directly. Then if I want to be fancy with this, right now, how do I treat my end conditions? Do I want a miter? Do I want to overlap? Do I want a notch? So for today's purpose, I'm just going to miter because it's quick. And I'm going to leave an 1/8 inch gap for welding. And I'm just going to put a window around my frames. And they're all mitered very nicely, and everything will adjust dynamically. Now for the verticals, again, I'm not going to do an awful lot of modeling here. I just want you to see the workflow and how this actually interacts with Inventor. I'm going to switch over to square tubes. That's rectangular. I'm going to do square. And the smallest I have is 2 by 2 by 1/8. This is all customizable. If you wanted to do 1 by 1 by 1/16, not a problem. If you wanted to bring in custom frames like the 80/20, those extruded aluminum profiles, that's not a problem. They can be imported and utilized in exactly the same way I'm doing this here. I'm just going to pick some vertical edges. And what I want to do is, again, I want to be on the outside. I'll accept that. I made a mistake on that one. We'll fix that shortly. I picked the wrong edge, but not a problem. Every member can be modified and tweaked. You're not having to delete or undo and start over. It's just a lot easier to modify. And that looks good there. So I'm creating this structure very, very quickly. This one's wrong, so I'm simply going to change it. I'm going to change its orientation. It's very graphical, right over here. That's my orientation, my little grip that I'm going to use, and it puts it right where it needs to be. So for the top, I'm going to switch that a little bit. For these, I'm going to switch over to, let's say, rectangular. And I'll do 2 by 1 by an eighth. So that also is wrong. Bring that down to there. That looks good. So I'm quickly building this frame. And I'm doing without any placing components, creating components, any assembly constraints. I'm using my skeleton, my box, my structure to define where things go. So as you can see, I have some end conditions that have some issues. So I'm going to fix that just by doing what they call corner joints. I'm going to do an overlap between here and here, and here and here. Now these are going to blend into here. So these I just need to trim. Actually, I'm going to shut this guy off for a second. This makes editing a little bit easier. I'm going to trim these two members back to that face. And this member back to there. And then at any time, as I'm doing this, I can always, if it's a really complicated frame, I could always inspect, analyze the interference, and I can see that I do not have everything finished. So one of my colleagues might have started this frame, he wasn't able to complete it. I'm going to finish it. So the first thing I want to do, are all the end treatments good? Do we have any intersections between these frames? We have one left over here, so I'm going to fix that. Actually, we have right over here. And just go back to my trim. And everything is now clean. What's nice about this, everything is dynamic and associative. So what that means is if I make any changes to my structure, if I go to my skeleton and I edit this like I would normally, it's just a sketch, it's just a part file. I'll make this 80. I'll finish dimensioning this. Let's make this 50. 36. And 30. So once I do that, everything updates. It only takes a matter of seconds at that point. So I'm designing my framework, my structure, and I'm just placing the components where I need them and when I need them. And that's it. So that's the frame generator. Again, if you have any questions, you want more information about this, just reach out and we can do a much deeper, in-depth demonstration on this particular feature. The next one is tube and pipe. In this particular case, I have some structure already in here. A lot of this is just bent pipe. It's just basically copper pipe that's either flanged or soldered or welded, soldered in place. So I need to add another one for the filter over here. So I've got a line that comes in. I want to branch over this one, so I want another T. I need to know the size. That's a 1 inch. And this is about a 3/8. So I think if I do a T over here, that's going to be 1 inch by 3/8. I should be good. So all I'm going to do is just use the tools that are within Inventor to model this quickly. So this is a single pipe. And I'm actually going to place a fitting from the Content Center. These fittings are all built into the system. They can be customized. You can add your own, and you can publish them and use them just like any of the fittings that you see me doing today. So here's the Content Center. And I did save a favorite. It's this little T right here. It's a reducing T. And I specify it's going to be 1 inch by 1 inch by 3/8. All I have to do is move over the pipe. It'll automatically understand that and snap right to it. It'll break the tube accordingly. There's a lot of rules. If the pipe is too long, there's a rules that define that if it goes beyond 60, 70, or 80 inches, automatically add a coupling. it knows the engagement with the fittings. So this tube is actually inserted into this reducing T properly, so we have the right engagement. So that looks good there. So there's my reducing T. So now what I want to do is I want to place another tube that goes from here to this fitting over here. And I'm going to do that by creating a pipe run. Now I've taken the time to already create some styles in here. So in this particular job, 1/2 inch, 1 inch, and 3/8 carpet pipe is plenty. So I'm going to drop this down and I'm going to choose 3/8. And I'm going to create a route. And the only thing I have to do is wait for my menus. There we go. I'm going to route from here to there. Now it's going the wrong direction. It's going to flip it. It's coming in from the other side. Inventor will calculate the least amount of material to go from point A to point B based on the rules that I've defined. I'll hit OK to this and create that. So this looks good, but one of the problems is it's the wrong size. That actually needs to go on top of this fitting. So instead of being 3/8, it really should be 1/2 inch. But I'm going to show you something slightly different. I'm going to delete this run. And this time I'm going to create it slightly different because I want to force where I want the run to go. And this time I'm going to use 1/2 inch style. And I'm going to route it. Well, I got to change that fitting, but I can do that after the fact, or I can do it now. I'm going to go, actually, let's cancel this. We'll come back to this. And all I have to do is just change the size. 1/2 inch. And I'm done. Everything moved a little bit because, again, it's a little bit deeper, different engagement. So some of these tubes got a little bit shorter, some of them got a little bit longer, but it fits perfectly. All right, so now let's go back and finish that other route. Half inch, I'm gonna route it. Now from here, this time, I want to determine exactly how high up I'm gonna go. I'm going to come up, this is a metric assembly. I'm going to come up 200 millimeters. I might need to clear other things or have other equipment going into this design. So at this point, I simply want to rotate it down 90 degrees. And then from here, I want to go, but I want to go as far as to the center line. So I want to come straight across, but I need to know where it ends. But I can use these work planes to help me define that. So as I hover over that work plane, the length of that is automatically defined by the geometry in my assembly. And once I'm there, I can just finish it just by coming up here, and I'll let the system, I missed. I'll let the system auto route the rest of it. Because I missed, it came around and added another loop. So I'm going to cancel that. I'm actually going to just delete this little guy. And then I'm going to route from here. Easy fix. Again, it's easier to edit, and it's okay to make mistakes, especially in a demonstration, because you need to see how easy it is to come back from an oops. So there's the route that I'm looking for, the orientation that I want. Everything looks good. Now, I want to be on top of this fitting. I can trim and extend. I'm going to add 10 millimeters extension onto that pipe to make sure I'm on top of it. Everything looks good. And there's my new fitting. I did all of that without creating any part files. sketches, 3D sweeps. I'm just using intuitive design tools to create these assemblies very quickly. Okay. So let's talk a little bit more about design automation. When we talk about design automation, we're really focused on iLogic. Roughly about a third of everyone with a seat of Inventor uses iLogic regularly. I think I speak with someone at least once or twice a day in regards to iLogic. Just had a conversation this morning. Someone is looking at modifying some code and reached out to us for some support. So if you're not familiar with iLogic, what is it? It's a rules-based design engine that is one of the most powerful and effective ways to save on time. You can define the rules to quickly reconfigure your designs. This helps to satisfy the customization demands from your customers. You can even use it to generate an instant quote. This is a great tool to win more business. The quicker you can get your models done, the quicker they can get the manufacturing, you just win. You're responding to inquiries faster. The files are getting to the manufacturing floor faster. You're removing the bottleneck in engineering. It's also important to understand the scalability of the work you do in Inventor. What happens when you want to make your forms available to people who don't have Inventor? Now, I haven't shown you really any forms yet. I'm going to show you that next. What are forms and how do they work? This PowerPoint slide right here, this is showing an iLogic assembly and kind of how you would actually drive it. When you're ready to take that next step in automation, MicroCAD can assist you with what they call the Forge Design Automation. It's an API, it's a programming interface for Inventor, and this allows forms to be edited in the cloud. Now, if you've never seen iLogic before, I'm going to show you how this works. This is a quick little assembly. It was done in a couple of hours, and this is something that was actually real. One of our customers designs pressure vessels, and they make the same type of vessel over and over again, but every customer orders it slightly different. Someone might want baffles in it, some may not. They might want different sized nozzles. They might want different location for these nozzles. They might want lift and lugs, they might not. They want different heights. So in order to take a design, copy it, edit it, and recreate it, it can take hours to do that. We want to be able to do that with rules-based design quickly and effectively. So in this particular case, this was done with iLogic. Anyone can use this. They don't have to know how to use Inventor. And this form can actually be produced in the cloud. So Uliana, if she's doing sales or purchasing, someone calls up and wants this pressure vessel, she can get into this form outside of Inventor using the Forge Automation API. She can enter the information based on the customer needs, and this will create a package, set of files, drawings, everything that's necessary, and send it right to manufacturing. So in here, I'm going to define what I'm looking for in this particular project. So do I want lugs? No. Now I can hit apply through every step of this, or I can just drive it. So this nozzle, this is the bottom nozzle. Distance from the bottom is 8 inches. I want that to be 10. In my direction, it's right. I want that to be front. My top nozzle, I want that to be 11.5. Can't. It can only be, this is the rules. It can only be 8, 10, 12, or 14. I specify what this top nozzle can be. The tank, the base, what is the height of this? I want this to be 20 inches. What about the height of the tank itself? I want that to be 110. And I'll apply this. Unfortunately, this tank cannot be any more than 100 inches. Oops. I got dialogues popping up on different screens. There we go. So we're going to make this 96. When I do that, there's no errors, there's no messages, everything works fine, and everything updates. So this is iLogic. This is what they call rules-based design. You can take any part, any assembly, any drawing, and integrate iLogic to implement design automation in your files. Okay. Interoperability. This used to be one of the biggest hurdles for most companies. Translating files has always been a challenge. You get a step file, you get an STL, you get an IGES file. What do you do with it? How do you use it in your assembly? So Autodesk has come up with what they call Inventor AnyCAD. It changes all of this for the better. You can simply open the file and maintain it in its original form and associate it and link it to your design. If any changes are made, the model just simply updates. If I have a SOLIDWORKS part file in my design and my vendor updates that SOLIDWORKS file, I simply just overwrite what I have and my assembly updates dynamically. I don't have to re-import it, place it, reconstrain it. It just updates dynamically. Anything that I've created around it reflects that and updates appropriately. Sticking with interoperability, let's talk about BIM. Participating in BIM projects is now easier than ever. For those of you that are looking to get specified into the building projects, or you're collaborating with architects to design and make custom designs for buildings. Your designs may be highly detailed and ready for production. You love it, but architects don't. They can't use them. They're too detailed. In Inventor, they can be quickly simplified using automated tools and then authored as BIM objects. You can then specify that object to an architect and they can place it in their Revit assembly. Then there are those of you who create custom fabricated designs for building project like staircases, designs, or awnings. You're going to see one of those with Juliana and myself. That this was a real project that we did for a customer, and we could have used this technology in Inventor 2023. So many times you need the Revit data to work around, and beginning in 2023, data exchanges can now be sent directly from Revit to what's known as Autodesk Docs. Autodesk Docs is basically cloud storage, and that's where the files reside, and we can live and work with those directly. Using the Forge viewer, users of Inventor can then access that Revit view that they need. So if it's a really large BIM model, I only need a certain area for the staircase. I can define that as my view that I want to reference. It even remains associative. So if the Revit user updates the revised data exchange, the Inventor model reflects that as well. So this, of course, eliminates any need to email Revit files, revisions that need to be imported into Inventor. The last thing I want to mention for Inventor is collaboration. Again, you have this great design or idea. How are you going to then communicate it to your customers or other coworkers for review? The answer to that in Inventor is shared views. In just a few clicks, you have an online representation of your design that can be opened anywhere. People can access it, your design, and they can view it. They can also make comments. They can measure. They can section it. They can explode it. And they can even mark up or redline it if there are any questions or concerns.
Hey, James, you can share your screen now. Oh, should I keep showing the staircase? I already showed it.
Okay, so this is the staircase that I designed in Inventor, and we had it produced. It was a real project for a customer. This was a building in Boston. And unfortunately, this was done with Inventor 2022. So the parameters, the confines of this staircase had to be manually input. It would have been great to be able to bring in the Revit model, just a view that was necessary to use this. So when this model was being created and I needed to collaborate with the stakeholders, I need to be able to share that with them. They didn't have Inventor, but I needed to share it. So when they collaborate, am I still sharing my screen?
I was sharing mine, but now you're with yours.
Okay.
Continue with yours.
All right. Let's see. I'm going to have you share your screen in 1 second. So this was a staircase that was designed. Everything had to be fabricated, installed, and then as built, everything had to be done. So what we did, and using the collaborate inside of Inventor, we did this shared view. I'm going to show that's a little distracting to me. So in here, I was able to create a shared view. And for today's presentation, I shared it with Juliana. So she's able to view it, look at it, and I'm going to have her show her screen so she can She can show you how she's able to view this Inventor model by using any device. It's not platform specific. Windows, Mac, Android, any web access can view this model.
Okay, I'm showing it right now. And for example, you can rotate it 360.
I don't see your
There's
screen.
this little,
Oh, there it is.
there's a little cube right here where you can go right, back, front, button. There's this really cool thing, the explode button here. And this is my view as a what user, did you say, James?
This is the Autodesk viewer.
Exactly.
So you can share any model or drawing with anyone. It's just a URL. They can't download anything. You're protecting your intellectual property. You can hide part numbers, component names. So you're very, very easy to protect your IP with this. Again, they can't download it. They can't save it. They can't do anything with it other than view, measure, markup, and comment on it.
Okay, I'm going
All
to
right,
stop sharing. You're welcome.
Okay. Some photos of when the curved string was being fabricated. It's a rather big staircase, about 12 and a half feet high. I think it was like 14, 15 feet long. So it was quite big. And there's a little pocket in here that was created for the glass handrail or guardrail that was actually going in and being inserted in here. So these are some real photos of the fabrication that took place for that. All right. This is just quick. This is just a success story. ViewRail, I have trouble pronouncing their name. Very similar to what I did in my staircase. They use the product design and manufacturing collection to automate their 3D modeling and their CNC toolpath strategies for custom staircases. Their business has grown over 10 times since they implemented this strategy. FS Elliott using iLogic is another great example. Using iLogic, they were able to automate and they were able to decrease the amount of time to create very complex models like this impeller. They dropped the time down from days down to about 15 minutes. Complex geometry like these impellers are incredibly hard to create. Once you have the rules behind it, it's just a matter of plugging in numbers. You want to change the pitch of the impeller, change the height, change the thickness, change the material. It's just a matter of minutes at that point for it to generate the model. Let's talk about some of the integrated tools for Inventor that are part of the product design and manufacturing collection. So everyone, including myself, wants their assemblies to fit perfectly, but at what cost? If you're making a one-off, it's not so bad, but if you're making hundreds or thousands of a product, it's really important to consider your tolerances. Most of you know the impact your manufacturing tolerances have on machining cost. Like myself, you probably question how much it's going to cost to reach those high tolerance values. Or is a tolerance stack up preventing your assemblies from actually fitting or functioning properly? You're getting any binding? You know, do they fit? But what about expansion, wear and tear? So how will it actually perform? So the Autodesk Inventor Tolerance Analysis is designed to help you make well-informed decisions while specifying manufacturing tolerances. I'll show you what this looks like in a few minutes. You design a great product. What does it look like to transition to manufacturing? Some of you can benefit from the factory layout tools that are in AutoCAD and Inventor to help optimize equipment placement and production. Think about setting up for a new line. You need to have conveyors, equipment. Where are these components going to go? Laying that information out is very complex, very tedious, but using the factory layout, it's very easy in AutoCAD and Inventor, and they're tied together. So if this is something that you're interested in, please reach out. We encourage you to reach out to your MicroCAD rep, and we can get people in touch with you to go over this in much more detail. So most 3D CAD software has some entry-level FEA. Inventor's no different. Many of you use it, which is great, but every license of Inventor Professional, for example, it comes with stress and frequency. It's been there forever. But are you getting all the information for how your design will behave in the field? So let's talk about or think about warranty issues. Well, how will your product perform? How will it work? How long will it last? Warranty issues can be a nightmare to maintain and keep track of. Autodesk Inventor Nastran offers a complete set of simulation studies, including nonlinear, thermal, fatigue, and dynamic studies. They all offer a complete understanding of your product performance with accurate results. Autodesk Inventor CAM provides a seamless workflow for design to manufacturing because it is integrated Inventor. This is great because it includes functionality for 2.5 to 5 axis machining, as well as lathe and mill turn applications. We have a lot of companies that do sheet metal. So you have multiple flat components that come in different sizes and shapes. A lot of people use, or actually a lot of customers use, specialized software to nest. Some of it will be in their laser cutting machines, whatever they might have, their CNC punching, sharing machines may have it. You can actually do it directly inside of Inventor using the Inventor nesting. It's integrated, and it helps you to understand and get the best yield from raw material. So nesting studies can be created and then updated to reflect any changes to the design. And you can easily compare nesting studies to optimize efficiency. What is your percentage of waste? What's your percentage of yield? How well are you doing? And you can compare those. And once you have that, then you use Inventor CAM for laser cut profiles. So let's back up a little bit and talk about the tolerance analysis. So now I'm going to do some presentations. So simply put, it enables us to do trade-offs between manufacturing and assembly tolerances to reduce cost. And of course, it does ensure that your assembly components are going to fit. We've all done it. We've needed to do this. We all do tolerance analysis. But if you ever had to do this manually with a spreadsheet, you know it's time-consuming, it's messy, it's not easy, and it's very much prone to error. And the best part of tolerance analysis is it's built directly into the Inventor user interface. No additional software, no exporting, no importing. It then calculates the cumulative effects of geometric dimensions and tolerances included in the stack-up. It reads the tolerance values that you have already specified when you apply 3D annotation to your model to create a model-based definition, and it also includes GD&T. Tolerance values, they can be evaluated and edited directly inside the tolerance analysis panel. Any updates there, they stay in sync with your existing 3D annotations and GD&T in the model. Tolerance analysis, it helps you understand how contributing tolerances impact each stack-up loop. Calculations can be viewed as worst case, RSS, root sum squares, and statistical. So if you're already doing 3D annotations and GD&T, why not leverage all of that existing information within the tolerance analysis? These tools allow you to save time in manufacturing by machining to a lower but acceptable tolerance, reduce your cost on over tolerance components, and ensure proper fit and finish during final assembly. Again, this all ties into winning more bids. If you're more competitive with your pricing, you're going to win more bids because you're in the ballpark. You're not over designing, you're not over tolerancing. So in this demonstration, I'm going to take a look at Inventor Nastran. And the reason why some of these are videos is because setting up the Nastran, the meshing, the editing, the actual solving, that can take minutes, quarter minutes, half hour, hours, depending on how complex you get with your your meshing and the analysis you're looking for, these studies can take a while. So for the sake of time, we do have some of these pre-recorded so you can actually see those in action. Again, the Nastran is also embedded directly inside the user interface. And we're not just doing linear studies. We can test your designs for vibration. We can make sure that we can check for the high and the low cycle fatigues. We can see how many loads can it take before cracks begin to form. This is one I really like, is we can actually run a thermal heat transfer study, and then we can apply those temperatures to a thermal stress study. We can run a nonlinear study, and these are incredibly powerful and very accurate. Once the primary structure is set up, any changes, if you want to change, again, using frame generator to change the C channel to a different size, it's a different design automation, different structure, but this type of frame might be used in a lot of your designs, but depending on what goes on it and the size of it, you can now very quickly use all of the tools built together to analyze, optimize, and truly design the best part and product. And red doesn't mean bad. It's just a color, and it gives you an indication in your chart as far as what values you're looking at. Okay. All right. So far, we've discussed, we're doing pretty good with time. We're at about 40 minutes, so we're doing good. So far, we focused on the integrated capabilities that designers can utilize within the Inventor environment. Within the product design and manufacturing collection, there are other tools that extend what the customers can achieve whilst working directly with Inventor designs. So at this point, I'm going to take a look at some of those additional options. With customer workflows becoming increasingly more complex and cross-disciplined, there is a need to coordinate and reuse model data in wider parts of the organization. Obviously, to consume models elsewhere, they first must be generated, which is why we kicked this presentation off with Inventor. However, within the collection, Autodesk includes applications that cover a much wider spectrum, from helping companies maintain their 2D information to enabling model coordination with other disciplines such as architecture, as well as providing tools that can be used to produce high-quality imagery and animations. Although 3D design applications have been available to manufacturers for over 20 years, many companies, they still rely heavily on 2D. In many instances, delivery of a product still often requires a combination of both 2D and 3D design. Similar to office-based tools, we recognize it's all about using the right tool for the job. So continuing to use AutoCAD for specific use case is still a requirement for many of MicroCAD's customers. One of the benefits of working with AutoCAD and Inventor is users can take advantage of the associativity that both provide. So not only can 2D AutoCAD drawings be referenced into Inventor, and this assists in creating those models very quickly, but as the Inventor drawing environment saves a DWG file, that information can be generated and viewed directly in the AutoCAD, and they're both completely bidirectionally associative. As mentioned a moment ago, many of our customers work in a multidiscipline environment. One of the challenges they often face with these types of projects is coordinating and communicating designs for review. Although many CAD systems can import information from other sources, it is often difficult to manage change. And depending on the complexity of the information, it may become quite unwieldy, especially when you have a model that contains hundreds of thousands or even 1 million plus components. This is where Navisworks comes in. The application is not only built for design review and walkthroughs, but it can also be used for clash management of models imported from other CAD systems, in addition to non-CAD data such as point clouds. With 4D timelining, equipment information can be synced to your project management software. This will help you assist in simulating how the installation, or even if it's decommissioning, a process will be undertaken. All of this can be accomplished whilst the data remains associative to the initial model source. This one, this connected tools with electromechanical is getting a lot of traction with a lot of our customers. And we all know that the collaboration between mechanical and electrical teams can be challenging. But what if electrical and mechanical designs could talk to each other? That's why the electromechanical workflow between AutoCAD Electrical and Inventor was developed. It's also known as EMX Exchange, Electromechanical Exchange. Schematic diagrams can be created within the 2D toolset, AutoCAD Electrical, whilst a common interface and aligned catalog ensure both parties are aware of what's happening in each other's design. Not only are you able to share up-to-date information between the electrical schematics and your Inventor 3D model, but it also gives the mechanical designer the ability, they can now generate 3D cable routes, ensuring that if space is tight, they know where things gotta go, they can appropriate clearances, and they can be accommodated while also creating an accurate bill of materials at the same time. Let's take a look at the EMX. So this is a small little AutoCAD electrical project. We have a connector, we have some motor starters, we have some contacts, we have some terminals, we have a capacitor, and then in Inventor, we have a simple little assembly. So this was, let me close my share view. So some of this was already created for the sake of time, but I want to be able to bring in the wires. I don't need to reference the schematic. I want to run the wires from the correct pins to the correct components and be able to create a nail board. But because I can sync this with AutoCAD Electrical, I can tie them directly and all that can be done for me. It's as simple as creating a link. So from AutoCAD Electrical, I'm going to create a link. I'm just going to call this PDM-456. I'm going to put this file somewhere that's shared between myself and maybe the Inventor user, because maybe I'm doing electrical today. They're not necessarily the same person, but for today's presentation, they are. I'm going to go to Autodesk and share. This can be anywhere. It can be on a network drive, wherever it needs to be. And I'll create that link. And that's it. Now from Inventor, I'm not going to create it. I'm going to link to the file that was already created from Electrical. Four, five, six. And that ties them together. So now, if I go to my location view, I'm interested in the electric cabinet. So what I'm seeing in here is this little symbol references the logical component, and the little cube represents the physical component. So I have a capacitor right here. That's my logical, and that's my physical. All I'm going to do is just link these two together. And I just do that for the other components, like for my terminals. That's terminal 1, terminal 2, 3, and 4. Now, this assembly was, again, already done. For the most part, was finished. And I happen to know where those components are. But I'm looking at this motor starter. I do not have a physical component in here. I have a logical, so I need to add that into my system. So from here, I'm going to insert it from the catalog browser. So AutoCAD Electrical determines, as far as the catalog information, manufacturer, the part number, and that information is stored in here. I'm going to insert it from the catalog browser. It brings up the correct component. Now, I have not configured this yet. I'm just starting off with this exchange. So it's looking for this Eaton part number. It doesn't exist. So what I'm going to do is I'm going to link it because I have downloaded a solid model, or I may already have one in my library that I can actually use. So this allows me to bring it in, and they're automatically linked together. Now, the only thing I'm going to do is constrain these. Actually, let's just defer the updates. We'll put that over here. I always get that wrong. It's this guy. Did it wrong again. It's over here. There we go. All right, so now I have my components in here. Everything looks good. Now, because it's linked with AutoCAD Electrical, I can run the wires. AutoCAD Electrical determines where the wires go based on the components. So it ran the wires. I didn't completely finish it, so I'm actually going to finish this here. And my plug is not defined, so I'm going to plug this over here. There we go. Go back to my harness. There we go. Bringing in all the wires that are necessary for the plug, for the connector. That looks good. So when I do that create connection, it brings the wires from point to point. And based on certain rules, you'll see it kind of blends kind of nice. It tries to arc it, but that doesn't really work. I created this segment where I want the wires to go through. So I can automatically route any wire that's not routed. So it makes a nice, neat bundle. So wires go properly. They go in from the connector to each of their necessary component. But all of this information is being derived from AutoCAD Electrical. If the electrical schematic changes, it'll update the assembly. If I add a wire here, it'll update the AutoCAD Electrical design. So they're completely bidirectionally associative between the schematic and the 3D model. Okay. Again, any questions at all, feel free to put them in the system, and then Juliana and I will address those at the end of the presentation. Okay. So virtual prototyping has been something manufacturers have been undertaken for many years. When projects are one-off, visualizations are often required. They need to sell the concept before any manufacturing can take place. Or for mass customized products, taking photos of every possible variation it's just not practical. When 3D designs are generated to share virtual mock-ups, sometimes just capturing a screenshot is all you need. But what if you need something a little bit more professional? Perhaps you need something more photorealistic for a brochure, website, or you want to present a very unique customer experience that separates you from your customers. And this can even be integrated with augmented or virtual reality. Because of this, you do need a software application that is dedicated to visual effects for photorealistic renderings and videos. And fortunately, that's why 3ds Max is included as part of the collection. Let's take a look at an example of how a combination of the capability we discussed earlier can be used to develop a new product line. It all starts with a 3D scan. If you've ever taken a project like this, such as brownfield installations, you need to ensure any new equipment or design is going to fit properly. Scanned data can be viewed within Recap, just like any other 3D design, where you can measure, filter, annotate, and even reference coordinated projects. These point clouds can then be inserted into your Inventor assembly, enabling an understanding of how the new and existing conditions work together. One of the core capabilities of Navisworks is the ability to collect all of this data together in a single environment. From your 2D layout, the many different 3D disciplines, and the various point clouds. You can then set up clash detection between all the geometry and geometry reports are then shared with all the relevant disciplines before making any of the necessary changes to ensure a smoother project delivery and installation. This next example is how customers take advantage of 3ds Max. Whether you realize it or not, as part of the product design and manufacturing collection, you have access to produce cinematic quality renderings and animations. Not only are you creating something that provides a better understanding of how a design is going to operate, but organizations are using this type of output to deliver a competitive separation in their respective markets. So we talked about some of the tools within the collection that extend how designs created within Inventor are consumed. Next, I want to talk about tools that are available when you send your Inventor designs over to the Fusion 360 platform. Fusion 360, if you're not aware of it, it's an Autodesk cloud-based 3D modeling, CAD, CAM, CAE, and PCB software platform, which is also included as part of the collection. What we're going to cover next is how you can use and utilize this platform to extend the value of data generated within the Inventor environment. So first, with Fusion 360, let's talk about generative design. If you've never seen or heard of it before, it's incredible technology and it's built directly within Fusion 360. So it's not just optimizing an existing part, but it's something that can generate hundreds of design ideas. It enables engineers, we can explore significantly more options in less time than it takes to model just a few manually. The study setup not only accommodates material, so we actually set up the generative study. We're going to specify what different types of materials that we want to use. What are the safety factors? What are the concerns? And what are the potential costs will be? And also based on the manufacturing method. Am I going to do conventional machining or am I going to do additive if I have the ability for that kind of technology? Once the engineer selects what fits their needs best, the finished model can be further edited to accommodate changes as necessary. In this example, in the slide at the top, you can see that General Motors, actually, this is a seatbelt bracket, and by doing generative design, they made it 40% lighter and 20% stronger. Also, in addition to that, they made it actually easier. So instead of being 8 parts, it's now 1. So it's no longer an assembly. However, the second example is from MJK Performances. They were able to develop concepts faster, but they were able to select their final design based upon the cost and time it would take to manufacture. Generative and additive is not always the best. You have to go by with what you have. What are your capabilities? And for them, traditional 3-axis machining worked out very well. It reduced the cost, the weight was good, and the safety factor was met. So when it comes to making a component, depending on the requirement, you may want to utilize subtractive manufacturing or other times additive. It really depends on the actual product and what you're trying to achieve. The great thing is Fusion 360, it supports both. So benefits of additive within Fusion, you can take advantage of some of the more organic creation tools. That's where the generative comes in, especially doing additive. When you want to generate the physical print, not only are there printer templates, but you also have the ability to optimize the printing process itself, such as support structures, fill definitions, orientation, and packing options. Although not specific to additive, there are advanced capabilities within the product design extension. Some of you may have seen some of the things like this that you're seeing on the screen, which is a lattice. It has a lattice creation preview that you can actually do within the Fusion 360. I want to talk about subtractive manufacturing. That is getting a lot of attention, and we have two different platforms for this. We have Inventor CAM and we have Fusion 360 Manufacture, or Fusion 360 CAM. So not only can you take advantage of the manufacturing environment to generate toolpaths in order to mill or turn your parts, but there are now more comprehensive strategies and capabilities that support organizations' more complex machining requirements. The Fusion 360 CAM is just growing incredibly. So in addition to machining, more recent developments also include the ability to support the definition of on-machine verification and inspection processes. So if using Inventor models, there is still the advantage of being able to consume model data associatively. Users can appreciate any change in design, whether Inventor or Fusion based. So what does all that mean? Well, what's nice about this technology in Inventor, you have a choice now. Because you have the product design collection, you have a choice. Here's a particular part file that I wish to manufacture. So if I choose to, I can go to my CAM environment, I can create a setup, and I can start specifying all this information. I go to my stock. I need to clamp this in a vise, so maybe I'm going to add a 1/2 inch material. Maybe I want to round everything to 1/4 inch. It gives me my stock that I want to work with. So I have a license of Inventor. I have Inventor CAM, but I don't have the time to do this. One of my colleagues is the machinist, and he has Fusion 360. So what I would rather do is take my Inventor model, which is where I would like to create and edit and author, and then be able to send it to him so he could do the actual toolpaths for me. So in the past, it was kind of difficult. We had to export, save as, upload. It was very, very difficult. So now what we can actually do, I'm going to take this example here. Actually, I'm going to delete this setup. I decided I do not want to do this. I'm going to do Fusion 360. I'm going to set this up for subtractive machining being done in Fusion 360. This is going to send my Inventor model associatively to the Fusion 360 environment. I specify where do I want to place it, and I'll share that location with my colleague or an outside vendor who may only have Fusion. So it's saving it and it's uploaded to the Fusion environment, and I can even now open it in Fusion just to verify to make sure that it's there. And everything looks good. Fusion was already open, and it's now switching to that particular design. So because I told it manufacturing, it automatically went to the manufacturing workspace where I can now set up my stock and everything else. Now I can start actually creating it and machining it. For the sake of time, I already started this with another part. So in here, you can see, refresh. Oh, I'm in the wrong different folder. Excuse me. So in here, I started this wheel hub from Inventor in the same thing. So you can see this is my Inventor part file, and this is my Fusion design file, and they're completely linked together. So what I started doing is I created a setup. I have a facing operation. Then I'm roughing it. I'm roughing out the conical surface, and then I'm going to finish machining it. And I haven't finished it, but I just wanted to show you the workflow from Inventor to the Fusion 360. So let's take just a peek at this. I'll simulate it. It's even inside a little CNC machine. And we'll just run the simulation. I'll slow it down a little bit. So at this point, I'm able to work in Inventor share my designs with Fusion, either for simulation, analysis, CNC, toolpaths, whatever I need, but I can take my designs and share them. If I make any changes or iterations in Inventor, those iterations will get pushed to Fusion and the toolpaths will just automatically update. I don't have to send out new files and new export, new imports. Everything is dynamic and tied together. Speed this up a little bit so we can actually see it moving along. And if you've never seen this before, right now, the machining that I have, it takes all of the feeds and the speeds, everything that I've defined in my tooling, and gives me an idea about how long this will take to machine. And right now, because that conical surface is rather intricate, to get a nice finish, I'm just under 6 hours for machining. I can get times for each toolpath or for the entire setup. So far, we've looked at Fusion, how we can automate design with generative design, and how it can help derive additive and subtractive processes. But there are tools that extend design oh, I'm sorry. I put my dog upstairs, but I think he sees something. I will be right back. Oh, the joys of working from home. Okay. So the other thing with Fusion, and we're just about finished, we're a little bit over time, we also have the capability to generate electronic designs from the initial schematic diagram to PCB layout with layer definitions to the correct, to the creation of the 3D board itself. This is a quick little presentation showing you inside Fusion how you're able to design the PCB board and then from there create the 3D representation of it and bring it directly into Inventor. So bidirectional associativity is incredible. I'll just speed this one up a little bit since we're a little over time. So it was designed, starting with the actual PCB itself, create the 3D representation, fit it inside of a 3D model, and then bring it into Inventor to complete the design process. So if you're working collaboratively, there's nothing better than this product design collection. So hopefully for those of you considering your options, and how you can access these tools, there are now even more flexible ways that you can subscribe. You can pay as you go to yearly or multi-year offerings. If you'd like to speak to a colleague or your sales rep or anyone, just reach out to MicroCAD. We can definitely assist you with what makes the best sense for you and for your company and for your organization. At this point, thank you for your patience. We did go a little over. Are there any questions?
No questions at the moment. But thank you, Tim, for sorry, James. Last week I was with Tim. Thank you, James, for that wonderful presentation. And if you want to learn these topics in detail, you can always take a custom training with James or someone else on our team. We also offer group classes online. So yeah, be sure to be checking the MicroCAD website for future webinars. And that concluded our webinar today. Thank you, James, and thank you everyone for attending.
Thank you, everyone.
Bye-bye.
Bye now.